Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the formation of ionic bond. In the previous lecture we have done about the mode of formation of chemical combinations. So ionic bond is always formed by transference of electron. So I am writing formation of ionic bond always takes place by the transference of electron, by the transference of electrons from one atom to another. In the previous lecture I have also told that formation of ionic bond always takes place between metal atom and non-metal atom. Now what will happen? Metal atom always lose an electron and non-metal atom always gains an electron. So what are metal atoms? The atoms, or we can say elements, which have tendency to lose electrons and form cations. And what are non-metal elements? The atoms, or we can say elements, which have tendency to gain electrons, which have tendency to gain electrons and form anions. So when any metal atom will lose electron, it will form cation, and that electron will be gained by the non-metal atom and it will form an anion. Now let me take an example. The very universal example for ionic compound is sodium chloride. I am taking it as example number 1, and I am talking about sodium chloride. The word is sodium chloride. What's the symbol for sodium? It's Na. What's the symbol for chlorine? It's Cl. Now what's the atomic number of sodium? It's 11. So the electronic configuration of sodium will come out to be 2, 8, 1. Now what will happen? The valence shell, or the outermost shell for the sodium, is this third shell. Now sodium will try to lose this electron and achieve stable electronic configuration of nearest inert gas, neon. So what's gonna happen? Here sodium will gain a energy called ionization energy. We have done about the ionization energy in the previous lectures of periodicity. What do we mean by ionization energy? It is the energy required to lose an electron from isolated gaseous atom. So the sodium atom, after gaining ionization energy, will lose its one electron from the valence shell and will become sodium positive ion with an electronic configuration of 2 comma 8, which is stable inert gas configuration of neon. Now ionization energy, it is the energy, specifically I'm mentioning it's the energy gained, it's the energy gained in the process. Now let's talk about the chlorine. And one thing more, the sodium has lost an electron by gaining electrons. I'm mentioning minus electron, that sodium has lost its one electron from the outermost shell to form the Na positive ion. That's why I have mentioned minus sign in front of electron. So now let's talk about the chlorine. The atomic number for chlorine is 17. The configuration comes out to be 2 comma 8 comma 7. Now here we can see that that chlorine is having 7 electron in its outermost shell, and it is short of only 1 electron to attain stable inert noble gas configuration of argon. So chlorine needs to gain an electron. Then what will happen? Here I am mentioning the electron which have been lost by the sodium will be gained by chlorine over here. So I'm mentioning here that it has gained an electron from sodium and will become an anion with a symbol of Cl negative. The electron which have been gained by chlorine have came from the sodium atom, so it have become Cl negative with an electronic configuration of 2 comma 8 comma 8, the stable inert gas configuration of argon having atomic number 18. So here whenever an element gains an electron, the energy is released. I am mentioning whenever an element gains an electron, the energy is always released, or we can say liberated, and that is called electron gain enthalpy. We have done about the electron gain enthalpy in the lecture videos of periodicity. So now in case of sodium the energy is gained, and in case of chlorine the energy is liberated. So here, and let me mention one thing more, that sodium has lost an electron, so here it is a obviously metal, and chlorine which has gained an electron over here is an non-metal. So metal has lost an electron and non-metal has gained an electron. The electron lost by metal has been gained by the non-metal. Now what next will happen? Now these oppositely charged ions, that is Na positive and Cl negative, will have electrostatic forces of attractions between them. So here will be electrostatic forces of attractions. These are the electrostatic forces of attractions between oppositely charged ions, between oppositely charged ions, and is termed as electrovalent bond, or we can say ionic bond. Now what will happen? These are the electrostatic forces of attraction which does not have any directional preferences. So actually what's gonna happen that let me write that, I'm making an assumption that one mole of Na positive ions. How many number are there in 1 mole? That's 6.022 into 10 raised to power 23 Na positive ions, and obviously 1 mole of Cl negative ions, that is 6.022 into 10 to power 23 Cl negative ions will arrange themselves, both of them will arrange themselves in 3D lattice in an alternate fashion. Both of the, obviously the 1 mole of Na positive ions and the 1 mole of Cl negative ions will arrange themselves in an alternate fashion in 3 dimensions, giving rise to the 3D lattice. 3D lattice. Now, what's next I'm mentioning? Formation of 3D lattice. I'm writing formation of 3D lattice accompanies release of energy. Accompanies release of energy called lattice energy. Called lattice energy. So, when the 1 mole of Na positive ions and the 1 mole of Cl negative ions arrange themselves in an alternate fashion in 3 dimensions, giving rise to a 3D lattice, is accompanied by the release of energy called lattice energy. So, in an actual, then what will happen? In the next lecture of lattice energy, I am going to show you the 3D structure of NaCl. So, what happens in the 3D structure of NaCl? One Na positive makes electrostatic forces of attraction with 6 Cl negative ions. One Na positive makes electrostatic forces of attractions or ionic bonds. Electrostatic forces of attractions with 6 Cl negative ions, and on the another hand 1 Cl negative makes electrostatic forces of attractions with 6 Na positive ions in 3 dimensions. In 3 dimensions, and here also in 3 dimensions, which will give rise to a lattice, which will give rise to 3D lattice. A detail about it will be given in the lecture of lattice energy. So that's all about it. Now let's talk about the total energies consumed and liberated. So I'm writing in this case, in case of NaCl, the energy absorbed is only ionization energy by an atom by sodium atom to lose an electron. The energy absorbed is ionization energy, which is used by sodium to lose an electron from its outermost shell. To lose an electron from its outermost shell. Not total energy released. Energy released. Energy released are electron gain enthalpy. Electron gain enthalpy by chlorine atom. As chlorine has gained an electron, so energy will be released. Ionization energy by sodium atom, because it has to lose an electron from an outermost shell. So energy absorbed will be ionization energy by sodium atom, and energy released will be electron gain enthalpy by chlorine atom, and energy released also is lattice energy. Lattice energy during the formation of sodium chloride lattice. So here all over, what's gonna happen? The magnitude of energy released will be greater than the magnitude of the energy absorbed. So in a chemistry, what's gonna happen? I'm writing in chemistry, in whole chemistry I'm mentioning, in chemistry, whenever in any process the energy is released, comma, then that process is feasible and spontaneous. So in case of formation of sodium chloride, the total magnitude of energy released is greater than the energy absorbed. So in total process, energy is released. So whenever energy is released in any process, that process is feasible and spontaneous. What do we mean by spontaneous? Any process just needs an initiation, then it will go to completion by itself. That's called spontaneous process. So the formation of NaCl will be feasible and spontaneous by itself. So that's all about ionic bond. And a detail about lattice, that one Na positive makes electrostatic forces of attraction with 6 Cl negative, and one Cl negative makes electrostatic forces of attraction by 6 Na positive with 6 Na positive. Will be deal with great discussion in the very next lectures of lattice energy. There I am going to show you a complete drawn NaCl structure where I will prove that one Na positive makes electrostatic forces of attraction, that is ionic bonds, with 6 Cl negative, and one Cl negative makes ionic bonds with the 6 Na positives, due to which a very big and a large number of lattices are formed, and a huge amount of lattice energy is released, which favors the formation of ionic bonds. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.